Okay, let's unpack this. Imagine a tool, right? Something that could peer deep into the Earth. We're talking not just for oil and gas, but maybe finding water on Mars or even predicting future events. Seems pretty wild.
Yeah, sounds like something out of science fiction, definitely.
It does. But today we're taking a deep dive into a fascinating set of sources that present exactly that, a cutting-edge geophysical exploration method with some, well, truly extraordinary claims.
What's really remarkable in these sources, I think, is how they connect advanced geophysics with these much broader applications.
Right.
This technology, it proposes to solve complex inverse problems, basically figuring out the hidden causes from the effects you can measure in a way that, well, few have really tried.
So it's about seeing the unseen.
Exactly. Beneath the surface, literally, geologically speaking, but also maybe figuratively predicting things.
Okay.
Our deep dive today will look at how this tech works, where it's supposedly being used, and yeah, the very surprising capabilities its developer claims it has.
So our mission here is to give you a shortcut, really, to being well-informed about this incredibly ambitious technology and the vision behind it. We've got quite a stack of documents here, scientific papers, company profiles, even personal background details, and some geopolitical analysis, too.
It's quite a mix.
It is. It's a journey into high-resolution exploration, some really unexpected predictions, and, the complex human stories that always seem to weave around these kinds of innovations.
Oh, okay.
Right, let's start by unearthing the core technology itself. The main method described in our sources is called HRES-IP.
Right, that stands for High Resolution Electrical Survey with Induced Polarization.
And it's presented as, well, a very advanced method for deep geophysical exploration.
But the real secret sauce, the thing that seems to make it different, is an algorithm called Reflection on Actions of Lorentz Forces -1. Or RALF1 for short.
RALF1, okay.
Yeah, developed by Vadim Chernov, and it's got a Russian patent. It's described as a programmatic way, like a software realization of a method to mathematically map the effects of Lorentz forces, which are, these fundamental interactions between electromagnetic fields and charged particles.
Right, basic physics.
Exactly. Mapping those effects into a compact property of, say, a physical body or even just space. So put simply, it's using fundamental physics to kind of read the hidden characteristics of things deep down.
Like a super advanced X-ray for the planet.
Something like that, yeah. For the Earth and maybe beyond.
And the capabilities they're claiming. Pretty ambitious stuff.
Oh, absolutely.
The sources say it can spot water or hydrocarbons down to 10 kilometers, maybe even deeper. And with an accuracy, get this, of just 2 meters on saturation.
Which, if true, is remarkable. That kind of precision, especially at depth, really goes beyond typical seismic methods.
So how does it actually work? What's the process?
Well, it uses electromagnetic fields, specifically low-frequency signals.
Okay.
And these are apparently transmitted and received using laser beams from satellites in orbit. That's called the AFS-IPLB method.
Satellites and lasers.
Okay. Yeah. Then on the ground, you need an earth source. That could be like an electric dipole in a well, or even a long grounded power line, maybe up to 30 kilometers.
Right.
And then they take ground measurements of an alternating electromagnetic field. They focus on the horizontal electric components, apparently. Those are the most informative.
Makes sense.
The tech studies things like resistivities, how resistance varies with direction, that's anisotropy, and polarizability in each geological layer.
And what about the gear, the actual equipment?
The sources mention needing a pretty hefty power source, like a big diesel generator, and a specialized 24-channel measuring device. Everything's kept in sync using GPS, naturally.
Standard practice there.
Right. And the ultimate goal, the whole point of this process, is to figure out the underlying causes of what they're measuring and automatically separate out their influence in the mathematical models without needing lots of extra assumptions or boundary conditions.
Okay, that sounds complex.
Yeah.
But what about noise? Any deep Earth sensing has to deal with interference, right?
Definitely.
They mention things like standard 50 hertz electrical noise, wind, traffic, even walking noise. How does RALF1 supposedly handle that?
They claim it can be effectively removed just by filtering.
Just filtering. That seems simple for such deep signals.
Well, that capability is really crucial because these geophysical inverse problems, they're inherently messy. They're called incorrect problems in mathematics sometimes, meaning the effects you measure from deep down are often incredibly faint. The sources describe them as decimals of a degree, so they're smooth, weakly differentiated functions, really hard to pick apart precisely.
Right, lost in the noise.
Exactly. So RALF1 aims to make the solutions clear and automatic. It claims to independently solve for unknown parameters with, and this is key, 100% non-correlation between them. It means it can supposedly tease apart different influencing factors perfectly, allowing it to remove the background noise and see the fine details. It's all framed within information theory, specifically the Shannon theorem about having enough data.
Essentially, it claims to find that tiny signal in a mountain of noise automatically.
That's the core claim, yeah. A very innovative approach if it holds up.
So, okay, that's the theory. Where has this technology actually been used, according to these sources? Here on Earth, I mean.
Well, the sources list quite a number of companies, actually. Big names in Russia like Rosneft, Lukoil, Neftogaz, Gazprom.
Major players.
Yeah, and others like Tumen Oil, Sedanco, Udmurt National Oil Company. And internationally, too, National Iranian Oil Company, NIOC, China National Petroleum Corporation, Medco Energy in Indonesia, Pertamina.
Wow, okay, so quite a global footprint claim there. Any specific examples of projects?
They give a few. For instance, the Dadasht 3D HRES IP project in Iran. Sounds like a pretty big operation, Russian and Iranian crews covering a fair bit of ground each day.
And what was it used for there?
The usual suspects in oil and gas. Mapping oil-bearing contours, identifying productive layers, looking at fluid saturation, detecting faults, even finding fractured zones, which can be important reservoirs.
Okay. Anything particularly unusual?
Well, one thing they highlight is its supposed ability to find oil in granite formations.
In granite. That's notoriously difficult, right? Very expensive to explore traditionally.
Extremely. But they cite the White Tiger Basin in Vietnam as a place where oil is found in granite down to maybe 1,500, 2,000 meters. And they suggest this tech is good for that.
Interesting.
They even predict similar resources based on this in Ukraine's Ravoruska zone. That's a specific geological area. They estimate something like 200 million tons of oil potential there.
200 million.
Yeah, and they talk about maybe 20,000 barrels a day from a single well drilled into granite. They claim the precursor method they used for that prediction had over 75% accuracy.
Those are big numbers. What about the economics? Does it pay off?
Well, they give one example from Western Siberia.
Right.
They claim work costing $4 million led to finding over 4 million tons of additional oil,
Wow.
which they calculate resulted in an economic efficiency or gain of over $1.5 billion for the client.
$1.5 billion from a $4 million investment.
That's the claim. It's staggering, if accurate. There's also a mention of an investment project in Ukraine, the Bylovsky Block, looking for about $134 million, targeting over 3 million tons of oil in 10 years, using this HRES IP method.
Okay, so huge potential economic impact in the energy sector. But you mentioned earlier, this technology isn't just about finding stuff underground.
Right. This is where it gets, well, even more extraordinary.
The sources claim RALF1's capabilities go way beyond geophysics.
They really do. The developer, Vadim Chernov, frames RALF1 as a mathematical observer.
A mathematical observer, what does that mean?
He makes a pretty provocative link to the famous Young's double-slit experiment in quantum physics.
The one showing wave-particle duality, where observing changes the outcome.
Exactly. Chernov actually states, according to the sources, that he replaced Observer with program code and claims that by doing so, RALF1 solves the main mystery of quantum physics.
Okay, hold on. Solving the measurement problem in quantum mechanics with an algorithm.
That is the claim presented in the source material. It's a massive assertion.
Understatement. So, if this observer code exists, what does it supposedly predict for us here on Earth?
Well, the claims are incredibly broad, forecasting upcoming events across different fields.
Like what?
Financial markets, for one. Predicting crypto prices, Bitcoin, Litecoin, Ethereum, and oil prices.
Seriously, it predicts markets.
The source cites a specific RALF1 forecast from April 2019 for Brent and WTI oil. It apparently predicted an unexpected level, which was then reportedly followed by a drone attack in Saudi Arabia that did affect prices. This is presented as an ability to detect black swan events.
Those rare, unpredictable, high-impact things. Wow. Okay, what else?
Meteorology. Forecasting atmospheric phenomena. They give an example of a San Andreas fault prediction that apparently differed from NOAA's official one but was later verified, according to the source.
Predicting earthquakes or related phenomena.
It seems implied. Then there's medicine. Potential use for predicting cell growth, maybe forecasting tumor recurrences to save lives. They cite some related cancer research contextually.
From finance to geology to medicine. It keeps going.
Oh, yes. It's proposed for something called globalpredictions.net, studying Earth and the universe from space to tackle all sorts of problems. Meteorites, earthquakes, floods, even pole shifts, wars, epidemics, famines, major crimes.
Basically predicting global catastrophes.
The suggestion is it can see these threats much earlier than any simulation allows. And finally, there are even claims of military applications.
Military.
Specifically in Ukraine. The algorithm is stated to be able to predict the intensity and main areas of Russian bombings based on historical data. This was apparently recognized as useful by Ukraine's Security Council.
Okay, predicting everything from stock prices to bombings. How do they justify such broad predictive power?
It's connected back to Occam's razor, the idea that the simplest explanation is often best.
How does that apply?
The suggestion is that for complex phenomena, RALF1 provides a simpler underlying explanation or predictive model compared to traditional methods. The core idea seems to be its ability to analyze open systems without being constrained by what they call the scientific stereotypes of conventional simulations.
So it claims to bypass the limitations of normal predictive models.
That seems to be the gist of it. Imagine being able to predict a black swan event. That's the kind of power implied here.
It's a lot to take in.
Yeah.
And it doesn't stop at Earth, does it? You mentioned Mars earlier.
That's right. The sources suggest an even more ambitious application, exploring Mars.
Using RALF1. How?
The proposal is to use it for Mars orbit via satellite to find deep sources of water, gases, maybe salt deposits.
Why those things specifically?
The motivation stated is clear. Finding a sufficient molecular water source is critical for establishing any kind of sustainable human colony on Mars.
Makes sense. Water is key. What about salts?
Ah, yes. The film points out that sodium salts, if found, are great for making batteries.
Batteries on Mars.
Right.
Power is crucial too.
And if we connect this to the really big picture, the ultimate goal stated in these documents is, well, ambitious barely covers it.
Go on.
It's about potentially creating the good atmosphere and climate for our life on Mars.
Terraforming.
Essentially. And even potentially creating a natural feeding medium for living organisms if hydrocarbons are found. Looking for water under high pressure and temperature as a source of energy, oxygen, fuel.
So not just finding resources, but potentially kickstarting a whole ecosystem. It's a sci-fi level vision.
Absolutely. Stemming from this one algorithm, RALF1.
So who is the mind behind this algorithm, Vadim Chernov? What do we know about him from the sources?
The sources give some background. He has a master's and bachelor's in geological and geophysical sciences from Moscow State University. Won an award for his diploma work from the Euro-Asian Geophysical Society.
Okay, solid academic credentials in the field.
And professional experience working for both Russian and Ukrainian companies involved in oil and gas Geoneftogaz or Daska Naftogazova company.
Right. Standard profile for someone in that industry.
But then there's a twist, a significant one.
What's that?
The sources state that Vadim Chernov was a political prisoner in Ukraine from 2022 to 2023.
A political prisoner during the war. That's serious.
It is. The sources also include details from a DNA analysis report for him.
DNA. Why?
It's presented without much context for why, but the results show primarily Eastern Slavic and Western Slavic heritage, with smaller bits of Baltic, Scandinavian, Basque. It explicitly notes 0% Jewish DNA markers, although the report adds a standard disclaimer about how those markers relate to historical community locations.
Okay, that's unusual information to include. But the political prisoner detail, that leads us into a more complex area that the sources touch upon, doesn't it?
It does. It connects to the broader context of policies and tensions in the region, specifically Ukraine.
The sources discuss Ukraine's current Ukrainization policy. Can you outline that?
Sure. As presented, it's a policy aimed at strengthening national unity. Key elements are promoting the Ukrainian language, decommunization, removing Soviet-era symbols and narratives, and generally repelling Russian influence.
Which, in the context of the ongoing invasion, seems like an understandable goal.
Exactly. The sources frame the goals as a comprehensible, perhaps even necessary reaction to an existential threat.
But
Huh?
I sense a but coming.
But the sources also present criticisms regarding how some of these policies are being implemented.
Such as?
Concerns are raised about mobilization tactics. The sources mention comparisons being drawn to controversial historical practices like the Lapki raids of WWII, and they cite reports of, I think, nearly 20,000 men attempting to leave the country illegally, presumably to avoid conscription.
That's significant. What else?
Concerns about the political climate under martial law, things like near-unanimous votes in parliament, the banning of 11 political parties deemed pro-Russian, and what the sources call unconfirmed hints of persecution of critics. The risks identified by these criticisms are things like public alienation, loss of trust, and potentially a weakening of democratic standards, even while fighting an external threat.
It's a difficult situation.
Mm-hmm.
And this leads to a historical comparison mentioned in the sources, right?
Mm-hmm.
The 1968 Prague Spring.
Yes, it does. A very pointed comparison.
How do the sources present that?
They lay out the facts. August 1968, Soviet Union and other Warsaw Pact countries invade Czechoslovakia.
To crush the reforms.
Exactly. To suppress the liberalization happening under Alexander Dubček, his socialism with a human face. He was allowing more freedoms, multiple parties, but notably hadn't publicly pushed to leave the Warsaw Pact. Moscow saw it as anti-Soviet.
Right. And the invasion first.
Mostly Soviet, but also troops from Poland, Hungary, East Germany, Bulgaria. And crucially, the sources state that the leadership of the Ukrainian SSR took an active part in the preparation and implementation of the invasion.
The Ukrainian Soviet Socialist Republic.
Yes. Units from the Odessa military district participated, and detained Czech activists were apparently first taken to Ukraine. They even quote a Czech communist leader, Wojtek Filip, as saying Ukraine bears greater responsibility than Russia for that 1968 invasion.
Yeah, that's a heavy historical point. But the sources are careful here, aren't they?
Very careful. They explicitly state this analogy is not an equivalence. It says, quote, the sources do not equate today's Ukraine with the former USSR.
So why bring up Prague Spring at all then? What's the point being made?
It's presented as a historical case study, a kind of warning about what the sources term state muscle memory.
State muscle memory, meaning?
The concern raised is that patterns of state control, maybe even patterns of coercion or violence, could potentially repeat themselves under completely different circumstances.
So the paradox they're highlighting is
that in the very fight against a system seen as authoritarian, like Russia's, there's a risk, according to this warning, in the sources of using methods that might themselves resemble authoritarian control. It's about pattern recognition, not saying the systems are the same.
it's an incredibly difficult tightrope to walk, isn't it? Especially for a nation fighting for its very survival in wartime balancing security needs with maintaining social trust and democratic principles, especially if the methods used stir controversy.
It truly is. And if we try to connect this back to the bigger picture, the promises of this RALF1 technology, they are incredibly bold.
Yeah.
You know, a glimpse into a future where deep resources are easy to find, maybe even where unpredictable events can be forecasted.
It sounds revolutionary.
Yeah.
And this seems really important. Our sources also include a major caveat, don't they?
They do, a crucial one. Despite all the impressive claims the case studies mention, RALF1 apparently lacks independent validation. Meaning, while the potential sounds amazing, the widespread, proven effectiveness, especially for those more extraordinary claims predicting black swans, solving quantum physics that just hasn't been confirmed by independent parties, it remains largely based on the developers' own assertions and the case studies provided in these sources.
So the excitement needs to be tempered with a healthy dose of skepticism for now.
Exactly. And this whole discussion, the technology, the geopolitical backdrop, the complexities of identity and policy, it just reminds us that knowledge, especially cutting-edge stuff with high stakes, always has layers to unpack, assumptions we need to question.
So what does this all mean for you listening to this? You've now taken a deep dive into this advanced geophysical method, HRESIP and RALF1, that claims to see incredibly deep underground and maybe even predict the future.
Uh-huh.
You've also gotten a glimpse into the really complex human and political world surrounding innovations like this.
And it really leaves us with some big questions, doesn't it? How do we as a society navigate that tension? The understandable need for security, for self-preservation, especially in crisis,
Right.
versus the absolute need to preserve democratic values, maintain trust, especially when faced with powerful new technologies that might not even be fully proven yet. What kind of future are we actually trying to build here on Earth and maybe even beyond?
Lots to think about there. That's it for another deep dive. We hope this exploration has given you a fresh perspective and plenty to ponder.
Keep asking those questions, keep digging deeper, and remember, there's always more to learn out there.
Until next time, stay curious.